students, today we are going to see remaining questions from JEE Mains 2026 phase 1, that is January 21st morning shift. Remaining questions, let us check. Okay, now the first question: which of the following resonating structure is the most stable? So option 1, 2, 3, 4 they have given. So which is the correct option? Resonating structure. Just I wanted to bring that idea how to identify that resonating structure. So as we observe this now, the side, where is my cursor? I just bring this point. So resonance structures are different Lewis structures of the same molecule. The connectivity of atoms says that the same, it is only what it is, electrons that movement around, electrons move around, that is only we are mentioning. So now the same question only, I just to bring it to you. So here octet rule, 8 electrons should be around, then only it will be stable. You know very well, that is the rule. I just to bring it to you here right now. Here that is what it is. Here 6 electrons are there, right? 2 lone pairs of electrons. So 2 lone pairs of electrons, 1 lone pair of electron, it's ready to transfer over here. By the time here alternative double bonds are more stable. So octet rule, we have to see that we have to maintain 8 electrons around the atom. So naturally the double bond transfer over here. The same way here, alternatively the double bond comes. So naturally here, so when it comes over here, you will get that negative charge. See, due to that losing of 2 electrons, so you're getting positive charge. And the same way now you just observe here alternative double bonds, and this is more stable. Right now the same way here also, say transfer of electrons, and over here, so you're getting positive charge due to that transformation of electron, and you're getting minus charge due to the gaining of electrons. This is only the fundamental rule. Right now the same way here also. Now you see here, when you observe this double bond transfer of electrons, here positive charge, it wants that electron. So naturally, so here you are losing the electron, you are getting positive charge over here. So you are gaining that electron, so you will get negative charge. And the same way here, now you see, now it is filled. No need to mention negative charge because it is filled. Right now it wants actually like electrophile, nucleophile, what do we say? Nu minus, electrophile E plus. So positive charge, when it receives electrons, it will be like it has filled that electron. Nucleophile, it is donating that electron. And the same way here also, lone pair of electrons, when it is transfers. So naturally here double bond, here also double bond, automatically it transfers. So alternative double bonds are more stronger. That is a simple basic idea. Okay, the same way here also lone pair of electrons. So here 2 lone pair of electrons. Why? Because it is a minus charge, because already electrons are there. This is next to that another added, so that is what minus charge. It is losing the 2 electrons, so it is, that is what it plus charge. So maintain that charges are more important. That is what I just to bring to your idea right now. I just to bring that idea of what it is, a rule, octet rule and resonance structure. Do not exceed the octet of carbon, nitrogen, oxygen and halogen. So carbon has no octet, that means 6 electrons only available here. This carbon, 6 electrons only available. So naturally transfer of electron. When it is transfer of electron, this point you are getting positive charge, and you are getting, it is hydrogen, it is hiding over there. Right now here double bond, you are getting the carbon with less than 8 electrons is okay, as long as you are correcting the charges. Charges are very, very important, right? So that makes you to give that alternative way to give what it is, 6 electrons, 8 electrons, like octet it is maintaining. So carbon with more than 8 electrons, that means 4 bonds, it is not okay. Now for example here hydrogen, 2 hydrogen are there, and here also 1, 2, 3, 4, 5. So that means here carbon with more than 8 electrons, that is 4 bonds, it is not okay. So naturally when you are turning this, I mean transfer of electrons, so this will not be okay. So watch out for hidden hydrogen. So CH2, like if you are writing CH3, CH2, CH2. So when you are drawing the what it is, line structure, so CH2 here, CH2 it is hiding over there. Watch out for hidden hydrogen atoms. That is what it has mentioned. So now for example OH it is there, OH it is there, means lone pair of electrons are available. So lone pair of electrons transfers. So naturally here you will get a double bond, and then this will be wrong. So here you will get double bond, and here also hydrogen is available, CHOH. So already double bond and CH. So this will be wrong. So carbon, nitrogen, oxygen cannot exceed octet. So more than 8 electrons it cannot accept. And the same way here. So here all, that is what I just mentioned. Alternative double bonds are stable. Simple way to identify, simple way to understand. So here lone pair of electron transfer, so naturally it is. So here the same way. Here positive charge, double bond, and here you will get minus charge. Oxygen is positively charged. It is okay as long as your correct charges. So charges you have to maintain. So charges you have to be pakka, where you are giving when the electrons are donating, when the electrons are transferring, you will put positive charge. When the electrons are gaining, that means you are already having lone pair of electrons. Again, you are adding, means that is you are getting minus charge in that way. Okay, now here NH, lone pair of electrons are there. So automatically it starts over there. The same way here also. So you will get positive charge and you are getting negative charge. See where it is negative charge. Don't here transfer of electron takes place. No, so that is okay. Now the same way. Okay, what it is? First row of element, that is can leave. That is nitrogen. It is a first row of elements, right? Have non-standard bonding as long as the lone pair of electrons, that is lone pair of electrons, charges are correct. So these are all you have to maintain. These are all a simple way to identify. So the same way here also, lone pair of electrons, it transfers over here, not in this way. Nitrogen is already surrounded by 8 electrons. So this will not be that correct. Whereas here, lone pair of electrons are there, here 10 electrons. Carbon, nitrogen, oxygen cannot exceed 10 electrons. That means cannot exceed octet 8 electrons. I hope you got the clarity. Now, which is the correct option among these? Okay, come on. Let us check. I think from this only, this is the exact answer they have provided. Okay, let us check which is the correct option. So the first option, what it is, structure 1, it is actually completely octet. Here also completely octet, and here negative charge, oxygen is having more electronegativity, it shows. Okay, actually this structure, it is most stable because it is completely octet, whereas here actually it is incomplete octet. See, both the side adjacent atoms are positive charge, positive charge. This will not be possible for most stable structure. And the same way here also, right? This also it is not stable. Of course, that fourth one, it is 2 plus charge. How is it possible 2 plus charges? It is not at all possible. Right now, option A, it is most stable because it is completely filled, and yes, the option it is 1. Right? I hope you got the clear idea, and you please check that rules. I have given that idea for you to understand. Yeah, come on, let us go to the next question. The next question, consider the following statements. Propanol and propanone are functional isomers. Ethoxyethane and methoxypropane are metamers. But2-ene shows optical isomerism. But1-ene and but2-ene are functional isomers. Pentane and 2,2-dimethylpropane are chain isomers. See, really it is very interesting question and easy question also. All these example questions they have given, and it is we have to identify which is the correct option, correct statement. Okay, first and foremost, you know very well this is propanol and propanone. Propanol, Al, it is aldehyde, you know very well, right? So Al, it is aldehyde. One, that is ketone. So propanol and ketone and aldehyde are functional groups 100%. That is, you know very well, CH3, CH2, CHO, that is propanol, first one. And propanone, CH3, C double bond O, CH3, propanone. So this is aldehyde functional group. This is ketone functional group. So you know very well. So this statement, it is 100% correct, the first one. And that is option, that means A. Okay, it's correct. And next one, ethoxyethane and methoxypropane are metamers. You know, metamers. Metamers means what? You know, metamers. So metamers means a compounds with the same molecular formula but a different alkyl chain either side of the central atom. That is, I just write and show you for metamers. What do you mean by metamers? Compounds with same molecular formula, formula, but different alkyl chain, different alkyl chain, right? Either side of the central atom, either side of the central atom, that is oxygen, nitrogen and sulfur. Okay, forming structural isomers, Right. Now here in this, what they have mentioned, ethoxyethane and methoxypropane. Okay, ethoxyethane. Ethoxyethane, what is this? CH3, CH2, O, CH2, CH3. So this is ethoxyethane. And methoxypropane. Methoxypropane. So methoxypropane, what it is? CH3, CH2, CH2, O, CH3. So this is methoxypropane. Okay, in that Here ethoxy ethane, right? That this is methoxy propane. So this is same molecular formula 1, 2, 3, 4, 1, 2, 3, 4, same molecular formula methyl group. But the central atom, it is what it is, oxygen, nitrogen, sulfur, in that any one among. So that is the structural formula. So this is completely based on what it is, metamers. I hope you got the clear idea. What do you mean by metamers? Metamers, it is nothing. Compounds with the molecular formula, same molecular formula. Okay, compounds with the same molecular formula, but different alkyl chain either side of the central atom, forming structural isomers. That is called what it is, metamers. Same, exactly. It is B option also. It is correct. Now C option, what it is, but2-ene show optical isomerism. How is it possible but2-ene shows optical isomerism? Optical isomerism requires what it is? Chiral carbon, right? So this is but2-ene, right? But2-ene, right? Carbon CH3, CH, double bond CH, CH3. Okay, so but2-ene does not show optical isomerism. It has contain what it is, plane of symmetry. Plane of symmetry has no chiral carbon. Chiral carbon means what it is, 4 different groups or atoms attached to that carbon, right? So that is called chiral carbon. This is, for example, A, B, E, D. So that is different groups or atoms attached to that. Then only you can identify what it is, optical isomerism. But it does not show optical, but it can show geometrical isomerism. It can show geometrical isomerism. But in the question, they are asking about what it is, optical isomerism only. So in the geometrical isomerism, you can bring cis and trans, like twins, right? Cis and trans. In that way, you can bring it. Okay, so this C will not be the correct statement. Okay, now D option. What is it? D option. D option. Here, but1-ene and but2-ene are functional isomerism. See, this is not a functional isomerism. Actually, what it is, here, but1-ene, but2-ene are positional isomerism. See, here it is first carbon, but2-ene, double bond comes in the first carbon, and but2-ene, here, but1-ene, double bond comes in the first carbon next to that, and here, but2-ene, just now we draw now, that is structural formula. So, second carbon, you will get the double bond. So, that will not be that functional group. Functional group means OH, that is alcohol, or next one, what it is, aldehyde or ketone. So, that kind of amines, these are all functional group. Whereas here, this will not be the functional group, right? Okay, so D option, it is not correct. Directly, I just mentioned, because this is very simple, that is what. And the pentane and the 2,2-dimethyl propane are chain isomers. This is a famous, familiar, exemplar question, right? So pentane, 5 carbons are there, CH3, CH2, 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 CH3. So, and the neopentane, C, here 1, 2, 3, 4, CH3, CH3, many times we have done in grade 11. This is neopentane. This is long chain structure, and this is what it is, branching chain structure. Actually, what it is, this is 100% correct. Pentane and 2,2-dimethyl propane. So 2,2-dimethyl propane, 1, 2, 3 propane. Right now, this is actually 100% chain isomer. So E, it is correct. Only D, it is wrong. So A, B, and E. C also it is wrong, and B, D also it is wrong. C also I just mentioned wrong. Okay, so which are the correct points means here C also wrong, right? So C also wrong. So which are the correct? A, it is correct. Metamers, this is 100% correct, and E, it is correct. A, B, E. A, B, E, where it is option 3, right? A, B, E, exactly, it is correct. I hope you got the clarity about all this. Actually, this is very interesting and easy question. Come on, let us go to the next question. I think you have done all these questions. You will get 4 mark, 100% if you have selected this point. Come on, let us go to the next question. The next question. Given below are two statements. Statement 1, when electric discharge is put on hydrogen, it emits discrete frequency in electromagnetic spectrum. Statement 2, frequency of He, that is helium plus ion, of second line of Balmer series is equal to first line of Lyman series. It is really interesting question. Here, generally, this statement both are represents hydrogen spectrum. See, you know very well that is Lyman, Palmer, Paschen, bracket, Fund series. That you know very well. The same idea. Helium plus, that means plus is what it is, atomic donor. That means H, hydrogen, it is 1, atomic number 1. Helium, it is hydrogen, atomic number 1. Helium, atomic number 2. But He plus it has given. So that means it related to that hydrogen. So that means N equal to 1, that series only. So here both the statements are correct, or both the statements are incorrect, or one is correct, the other it is correct, or the second one it is correct or first one it is wrong, right? That's such kind of question. It's really simple. Both the statements are correct only. Electric discharge is put on hydrogen. It emits discrete frequency in electromagnetic spectrum. 100% it is correct. And the frequency of helium plus, as I mentioned, helium ion. This is helium ion. So naturally, atomic number 1 only it represents. So the second line of Balmer series is equal to first line of Lyman series. So first line Lyman, the second line Balmer. So actually, atomic number 2 it is Lyman series, Balmer series only. But here helium ion no. So naturally, n equal to 1 only. So the series is equal to first line of Lyman series. So both the statements are correct only. I hope you got the clarity. Okay, just to bring that idea for you to understand. So this is Lyman, Balmer, Poston, bracket, fund series. So this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, 5, 6. So this is the way we can identify. So both the statements are correct only. So the answer it is both the statements are correct. Yeah, statement 1 and statement 2 both are correct. Why? Because actually the frequency also same. What is that frequency? He, helium plus. So helium plus ion it is same as hydrogen atom. This is hydrogen atom. So because hydrogen atom is what it is, atomic number 1, and helium ion also 1 atomic number only. So naturally frequency will be same. Both the statements are same. So Balmer series is equal to first line of Lyman series only. As you mentioned, as we have seen that Lyman, Balmer, Poston, bracket, fund series. No, so in that. So first option, both the statements are correct. Come on, let us go to the next question. The next question, observe the reaction sequence. C4H8, when it reacts with HCl, you are getting C4H9Cl, halogen, right? And when it reacts with ammonia, you are getting alkyl amine. This is actually optically active. This is one keynote. And this one, this optically active compound, when it reacts with diazonium, diazotization reaction takes place. So you are getting like alcohol. So this is another one more keynote. So this is optically active one keynote. Another one, this is alcohol you are getting. So this is another one keynote. So from this, we can get that idea. How do we find out that answer? Compound A, what it might be. See, one thing I would like to tell you here, diazotization reaction, it takes place only in aromatic compound. C4H9, it would not be that aromatic compound, it is aliphatic compound. So aliphatic compound, when it reacts with diazotization, that means this is amine compound, right? So alkyl amine reacts with the diazotization reaction, it gives alcohol. So that means the final compound, it is alcohol. Okay, now this is which compound? A, B, C. Okay, now these two are, we can take it as a key point. Okay, now this is actually C4H9NH2, optically active. So optically active compound means that compound, that chiral carbon should not be that terminal carbon, neither it is there in the front carbon, it will be there in the middle carbon. So middle carbon, if it is possible, means the same way here also chlorine which will be attached with that middle only. So that means C4H8, what kind of compound? Okay, come on, let us check with that formula, general formula. CnH2n plus 2, it is alkane, right? Now CnH2n, it is alkene. Okay, so alkyne, it is CnH2n minus 2. Now here only C4H8, 1 into double. So that 4, 8. So naturally it will be alkene only. So alkene compounds, that mean double bond where it has to be present. It might be present in the middle. How do we identify it might be present in that middle? Because haloalkane, when it is combined with that, what it is? Ammonia, you are getting what it is? Optically active. So 100% it might be that alkene, that double bond nature, it should be there in the middle of that compound. Okay, come on, let us check how do we identify. So C4H8, okay, one by one, let us check. C4H8. So this is actually alkene, right? I mentioned, no? So alkene, it might be butene, right? CH3, CH, double bond CH, CH3. So that means 3 plus 3, 6, 7, 8. C 4 and H8. Come on. Okay, now in that, when it reacts with HCl, so naturally the double bond started breaking. So you will be getting what it is? CH3, CH2, CH, Cl, CHCl, CH3. right? So the Cl comes more over here or here, anywhere. So anyway, it is there in the middle, right? So the double bond started breaking due to this. Okay, now this is actually haloalkane formation takes place. According to what it is, the great rule, it is Markovnikov's rule, right? Okay, now next one, ammonia, NH3. So when it reacts with ammonia, so naturally you will be relieving what it is, HCl, and you will be getting what it is, CH3, CH2, CH, NH2, CH3. So naturally, this is actually what it is, chiral carbon. How can we say it's a chiral carbon? Because four different groups or atoms attached to that carbon. So naturally, that is called chiral carbon. Chiral carbon is a mandatory for optically active compound. Okay, one side, middle side carbon, one side hydrogen, the other side methyl group, and this side it is amino group, this side ethyl group. So that is naturally it is optically active group. Optically active group. Got it? Right. Okay. Now the next one, what it is? The next one, what it is? Diazotization. So diazotization, how do we go for it? So NaNO2 bar HCl. So this is nitrous acid when it reacts with alkyl amine. So diazotization reaction, when it is reacting with aromatic compound, you will get diazonium chloride. That is different matter. But when the diazotization reaction takes place in aliphatic compound, that is alkyl amine, you will be getting alcohol. So this is only that final product. So that CH3, CH2, CH, here OH, here CH3. Simple, right? Very interesting and easy. You know why? Aliphatic amines do not bring diazonium salt. Why? That is because it is unstable. When it is bringing diazonium salt also, it is unstable. So it releases nitrogen. It releases nitrogen at once and it reacts with water molecules and it will form what it is, alcohol compound. So at once it will react with water and nitrogen gas it releases. N2 gas it is releases and it reacts with the water molecule. Naturally, you will be getting alcohol. So this is the final compound. Hope you got the clarity. Now, how do we identify the option? So first one, it is CH3, CH double bond CH2. And the second one, 1, 2, 3, 4. Okay, for the compound it is, where is that option they have given? The option, I think the next page. No, next page it has not mentioned 1, 2, A, B, C, A, B, C. Okay, now the compound it is, here what it is, CH3, CH double bond CH3, and the second one, halogen, haloalkane, and the third one, it is alkyl amine, and the fourth one, it is alcohol. Yes, okay, now this is the answer. Come on, let us check with that PDF. Option, this is a double bond, it has to be there in the middle. It should not be in the terminal, right? Terminal means you will not get optically active compound. So option 1, it is wrong. Okay, option 1, it is wrong. Option 2, it is double bond comes in the middle, and see, wherever double bond it is there, only Cl, because it is like, what is it, Markovnikov's rule it follows, right? So second option also it wrong, because the B compound, it is Cl, it is there in the terminal, so it has to be there in the middle. Where there is a double bond, the double bond started breaking due to that, what it is, Markovnikov's rule. Right now, next one, C. This is also terminal and Cl. Of course, this also will not be the correct. Starting only we found. And of course, this is the middle double bond. It is there. Yes, it is correct. Of course, this is also correct according to Markovnikov's rule. So it comes in the middle. And this also. See, all these three are correct. Fourth one, alcohol. So through that, not only we found optically active. That is the key point. That is what I just mentioned. So easily we can identify. Actually, this question, it is really very interesting and easy to identify if you know the concept thoroughly. Concept, it is a basic idea to get the answer. Okay, come on, let us go to the next question. I hope you got the clear idea. Now, this is actually fourth option. Fourth option only is the correct answer. Okay, come on, let us go to the next question. Next question, benzene reacts with HNO3 or H2SO4. Option A, that means the compound A, when it is reacting with SN bar HCl, this is a reduction reaction. Okay, this is the compound B, that is reacts with acetic anhydride. This is a Friedel-Crafts reaction, right? Okay, so you're getting compound C. That compound reacts again nitration in both HNO3 or H2SO4. You're getting compound D. That compound D, when it is reacting with acid hydrolysis, you are getting compound E. That compound E, percentage of nitrogen in compound E, they are asking. See, really it is like a puzzle. From the compound A, we have to get that, compound A, B, C, D, E. From that E, we have to find out that percentage of nitrogen. So compound E might be nitrogen. 100% nitrogen is present. That we can come to know clearly. Okay, come on. Let us check here. Benzene. Okay, benzene, when it is reacting with the HNO3 or H2SO4, it is 100% nitration. So nitration means nitrobenzene only will be coming. Okay, nitrobenzene, when it is reacting with SN bar HCl, it is nitration. It is a reduction reaction. So nitrobenzene reacts with SN bar HCl, 100%, you will get aniline. Come on. We'll go for that reaction one by one. Here, benzene reacts with, this is nitration, right? So concentrated HNO3 bar H2SO4. Concentrated H2SO4. So what you will get it? Nitrobenzene, 100% you will be getting nitrobenzene, NO2. So this nitrobenzene, again it reacts with SN bar HCl. So this is a reduction process. So you will be getting what it is? Aniline. Aniline you cannot get directly unless it has to undergo what it is? Nitration. That you have learned, right? So this is aniline. So this is, I just mentioned, this is benzene. I'll write it each and everything. This is benzene. This is nitrobenzene. Nitrobenzene. Right, this is aniline. Right, okay, you got it. Now the next one, from aniline, it has to go for Friedel-Crafts reaction. How do we go for Friedel-Crafts reaction? It is actually what it is. Acetic anhydride, CH3CO, CH3CO, both connected O. Acetic anhydride, it is a Friedel-Crafts reaction that you have learned, right? Okay, now, right, now here hydrogen, one more hydrogen, I just write it over here. So it will be easy for us to identify. Okay, one more hydrogen. So NH2, no. So one hydrogen which is connected with this compound, right? CH3COOH, right? CH3COOH. So you will be getting what it is? CH3COOH. It releases acetic acid. Then remaining what it is? Acetyl aniline. Okay, what it is called? Acetyl aniline. Acetyl aniline. How do we identify its acetyl aniline? NH, here C double bond O, CH3. The same. Okay, C double bond O. That means CO, keto group, methyl keto group, which is attached with removal of one hydrogen. Here one removal of one hydrogen. No, so this hydrogen we removed in that NH, it is there. So in that CO, CH3CO, that is attached. Like aspirin, we have learned to know how do we bring that aspirin from phenol, salicylic and acetyl oxysalicylic acid. So in that way. Okay, now next one here in this point, it reacts with what it is? Nitration. Again, it goes for nitration. Concentrated HNO3 and concentrated H2SO4. Right. So what you will be getting? You will be getting, this is a para-directing group. Nitration, it is a 100% para-directing group. So nitroacetyl aniline you will be getting, right? So the same point I'm just bringing here, the same point. Okay, so this is NH, C double bond O, CH3. Directly I'm just writing. Here NO2, NO2, nitro group. Okay, so this is nitroacetyl, what it is? Aniline you'll be getting. So when it is reacts with acid hydrolysis H plus H2O, you'll be getting what it is? That is nitroaniline. What you'll be getting? Nitroaniline. Compound E. Yes, we got it. We reached to that compound E. So this is nitrogen compound. It is there. They mentioned, of course, it is nitrogen is present. So NH2 and here NO2. How do we get NO2? See this H plus ion when it is reacting with that. So here HOH, right? So HOH means what it is here? NH2, you're getting NH2 over here. And here what it is? CH3 COOH. You are getting CH3COOH again. Okay, now here nitro group due to that nitration. So this is the compound E. Compound E, it is nitroaniline as that compound. Okay, now we have to find out that percentage. So this is compound. This is the compound A and this is the compound B, aniline. And this is the compound C, acetyl aniline. And this is the compound D. This is the compound D, and finally this is the compound E. So now we have to find out the percentage of nitrogen in the compound Right now, how do we identify the percentage? Molecular formula for Nitrocarbon, that is C6H4 NO2 NH2. Right. Okay. C6H4 NO2 NH2. Completely when we are going for it, 12 into 6 plus 1 into 4 plus nitrogen, what it is? 14 plus here 32, right? Oxygen 32 plus 14. That's nitrogen 14 plus 2. Right. So here 72 plus 4 plus 14 plus 32 plus 14 plus 2 is how much it is? 138. Okay. So 138 mass of, I mean, percentage of nitrogen. How do we go for percentage of nitrogen? Yes. Here percentage of nitrogen. So percentage of nitrogen, how do we identify? Atomic mass. Atomic mass of nitrogen, it is 14. Into number of nitrogen atom, it is 2 divided by molecular mass of compound. It is 138. It is molecular mass of compound, gram per mole. Right. So here also gram per mole. And into 100 percentage, no. So you'll be getting what it is. Here 14 into 2, 28 into 100 divided by 138. So you'll be getting what it is, around 20.28 percentage. Okay, so here approximately here exactly it is 20 percentage of nitrogen present in that nitroaniline. I hope it is understood this point, and it's really interesting to go through. It is like a puzzle, one after the other. Like each box, there is some chocolate it is available. Like there will be a puzzle or something. Okay, this is such kind of question. Really interesting. Come on, let us go to the next question. I hope you understand all these questions. Some of the questions I didn't get from the PDF. Yeah, I will check and I will let you know later. The next question in our next video. And thank you for watching. All the best for your upcoming exams.